3-3, like I said, I thought was 3D graphing and solving 3x3 systems, but instead it's actually graphing linear inequality systems. So remember 2.8 where we did the graphing, right, and you shaded above or below? It's just graphing multiple of those lines on the same plane and telling me where the two shaded regions overlap. So it's really straightforward stuff. This system, if I ask you to graph anything, what variable do we always isolate? The y. So for the first equation being the red equation, is y by itself? Okay, so what's the m? Yeah, so what is the slope for this line? Close. Negative 2 over 1, right? So remember, save the x, right? We just found the number in front. And what's the b? Negative 5. Okay, is this going to be a solid line or a dashed line? Dashed. And where is y bigger, above or below? Above. Okay, so we're going to have a dashed line and we're going to shade above the line. Everybody okay? Yeah, because it's an inequality. Whenever you see a graph with an inequality, we're shading. Except this time we're shading two things on the same graph. All right, next equation is y by itself. So what do I have to do to get y by itself? Yay, add x. Whoops, wrong color. Hang on. All right. So now y is by itself, so what's the m? What? 1 over 1? Is that what it... I just heard mumble. I heard... That's what I heard, so... Yeah, okay. So x, or m is the number in front of x, right? So the coefficient on x is 1, so it's 1 over 1. So what's my b? Si, senor. Solid or dashed? Solid, shaded above or below? Below. Everybody okay with this so far, yes or no? All right, so now we just graph both lines on the same plane. So for the first line, you said it's going to be a dash line, right? Where do I start, m or b? B, and what's my b? Negative 5, and then how do I move? Do I go up or down? Down how far? 2, and then which way, left or right? How far? Okay. Coordinate plane, go down 5. 1, 2, 3, 4, 5. So there's my b. From my b, you said go down 2 over 1 to the right, or up to 1 to the left, right? Remember, if it's a negative, you only need one negative direction, though. Okay, so down is a negative for y, so we have to run to the right because that's positive for x. Or if we go up on y, which is positive, we go to the left on x because that's a negative direction. Grab my ruler. All right. So again, did you say solid or dashed? Dashed, right? Okay, now there's a couple of different ways of shading. All right, because I have the board. All right, I tend to shade with highlight. Now, if you want to, you are more than welcome to use colored pencils over there and shade in multicolor. Okay, so what I'm going to do is I'm going to shade with the colors, and then I'm going to show you a way to shade if you're using one color, so that way you can do it on your homework without colored pencils. Okay? So, for this line, did you say that y is greater than or less than? I don't remember. Let's take a look. Y is what? Greater than, right? So is that shaded above or below? So I shade above. Okay. So for the first line, this is my region. Everybody okay with that? Yes or no? Okay. For the second line, what was the B? 3. Okay, so I go up to 3, and I put a point. What was the M? 1 over 1. So I go up 1 over 1. Up 1 over 1, right? Again, solid or dashed line? Solid. All right. Come on. Good boy. Okay, so now... All right, so for the second line, right, is that less than or greater than? Less than, right? So is that shaded above or below? Below. So I go to my line, and I shade below. You know, I had issues in kindergarten of coloring. Yeah, I'm a sloppy kid when it comes to coloring. Okay, so you can see that I have the red line and the blue line, right? So where do the two overlap at? What color do they become? Purple, right. So what I want you to do is if you color like this, right, I want to clearly see the area that you're talking about. So take the time to highlight it. Yep, highlight the lines that form the region so that way I can tell exactly what you're talking about. Now this is a dashed line here, so I have to keep it dashed. Like I'm not allowed to turn the dashed line into a solid line. So if that accidentally happens, leave a note for me. Draw an arrow like you guys normally have and said, hey, this is dashed. Everybody all right with that? Yeah? Okay, so any major questions on how to shade? Because anything inside the shaded region is a solution. So what that really means is here, because it's a solid line, the point's contained, right? So this is a solution, this is a solution, this is a solution. Now, what if I'm on this line here? Is that a solution? No, because it's dashed, right? But anything else will be a solution. So anything in the purple region is a solution. Okay, everybody good with that, yeah? All right, so now I'm going to show you how to do this in a single color. Yeah, so you graph them one at a time, just like we did in 2.8. It's just that you're going to have 2, 3, 4 of them on the same graph. So you just do them one at a time and look at where they're intersecting at, and that's the region I want. Okay? So one thing you can do is instead of doing these with a single color and shading, right, with multicolors, if you're using one color, you can use vertical and horizontal lines or slant lines. So for the red line, right, was that greater than or less than? This was a greater than. So what that means is we're going to shade the area above it. So I'm going to come in here and as best as possible. Yep, so use a line type instead of actually shading. Use vertical and horizontal lines so you can see where they're crisscrossing at, because it'll actually make a checkerboard pattern. All right, so there's one, right? So where was the other line? What was that? B? It was 3, right? And then up 1 over 1, up 1 over 1. So grab my ruler here. This was a solid line. And then were we shading above or below? Below, because it's a less than, right? So if I used horizontal the first time, what do you think I'm going to use this time? So the solution is where both things show up, right? So what we're looking for is the checkerboard, right? Where do we have both vertical and horizontal stripes? So you can see that it's bound by this line. So I darken this in. And it's bound by this line. So I darken that in. And then on your paper, you could, like, make it real obvious for me. Because you guys should learn by now, like, if you're not sure if your teacher's going to know what you're doing, leave a note. So that is my shaded region. Everybody okay with that? So I'm talking about this in here. So if you do it in one color, it can look like that. If you want to use the color pencils and do multicolors, you can. Just make sure that I can clearly identify what your solution area is. You're going to start off with 2, and I think the biggest one you have to deal with is 4. So this is just another way of shading. This is the exact same problem we had up when you left. Okay, it's just instead of using different color shading, you can shade by using vertical and horizontal stripes. And what you want is the area where both show up, which is why I have this marked out with the black lines. Is because this is where our solution set is, because we have both vertical and horizontal. We get this nice little checkerboard pattern. Okay? So it doesn't matter. It's up to you as to which one you use. I'm going to let you know because I have the technology. I'm going to use shading. Okay? All right. So for the red equation, right, is y isolated. No. So what do I have to do to get y by itself? Okay, so let me change. There we go. Subtract 2x. Okay, do I have to change the inequality sign when I subtract 2x? Okay, do I have to flip the inequality sign when I divide by 3? How come? Okay, it's not negative. Very good catch. Well, all right. So now y is isolated. What's my m? Negative 2 over 3, and what's my b? 2. So remember, the formula is y equals mx plus b, so what's important is m is always attached to the x. Okay, it's not first or last, it's whatever's with the x. So over here is y by itself. Okay, so what's the m? And the b. All right, so red line, solid or dashed? Dashed because there's no or equal to, right? And then where is y less than? Above it or below it? Below, so it's going to be dashed below. Top line, or sorry, blue line. Solid or dashed? Solid and shaded above or below? Above. Where do we start? M or B? B. So what's my B value? 2. And then where do I move, up or down? Down how far? Okay, down 2, and then which way, left or right? To the, or how far? 3. And then you said it's going to be a dash line? So 2, 1, 2, 1, 2, 3. Dash. Alright, except I think I goofed, right? Was this a solid or a dash line? Dashed. So, un momento. Right, so for the blue line, where do we start? Okay, and then do I go up or down? Okay, is it a solid or dash line? And am I shading above or below? Okay. Don't mind, computer. Thank you. 1, 2, 3, 4. Down 2 over 3. Solid line. And you said shade above, right?
Yeah. Yep.
Too bad this looks more like France's national flag right now, but yeah. Alright, so where do the two regions overlap?
No,
Nowhere, so it's no solution. I don't think so. I think we have one more. Oh, no, yeah, I have to make sure that you know how to graph an absolute value function. For the red line, how many variables do you see? 1, and what is the variable? Y, so what kind of a line? Vertical, horizontal, or skew? Horizontal. All right, is it going to be solid or dashed? So it's going to be a solid line through 3, right, but horizontal. Are we shading above or below? We are going to shade below. Everybody good with that, yeah? All right, blue line. Is y isolated? Yeah, but what do you see? What do we have? Right, the absolute value function. So who remembers when we graph an absolute value function, what is the first thing we have to find? H and K, so that way we can find the vertex, right? So I'm going to start off with the vertex. So who remembers? Where's the H come from? Inside or outside? Inside, right? It's alphabetical, so H, K, inside, outside? H. So H flips its sign. So what's being added or subtracted inside? Positive 4. So what does it become outside? Negative 4. Everybody okay with that, yeah?
Yeah.
All right, so we're, what's being added or subtracted outside?
Nothing.
Nothing. So what's the K? 0. Nothing. Everybody all right? Now, why this is important is I have to put the vertex in the middle so that way I can go 2 points above and 2 points below and make the V. If I just use -2, -1, 0, 1, 2, I won't get a V. I'll just get a straight line, so your graph will be completely off. Okay? So plug in a -3. What's -3 plus 4? 1. What's the absolute value of 1? 1. Everybody okay with that, yeah? All right, plug in a -2. What's -2 plus 4? 2. What's the absolute value of 2? 2. So you do the same thing on the bottom. What's -5 plus 4? -1. What's the absolute value of -1? 1. Do the same thing with -6, and what do you get? 2. Okay, is this going to be a solid line or a dash line? A dash line, and are we going to be greater than or less than? Greater than, which means I'm going to be shading inside the graph. Okay, and I'll explain that more when we get to the next page. Yeah. H, by definition, is the number that's added with x inside the absolute value function. Now, if order doesn't really matter too much in there, okay? We're always going to put x first. So if it's 4 plus x, that's really just x plus 4 written in a different way. I think what you're thinking of is if it was like 3x plus 4, right? If it was multiplied. But because it's addition, order doesn't matter. So we just know that h is going to flip its sign. So all I'm asking for is what number is being added or subtracted with x. So it doesn't matter whether it's 4 plus x or x plus 4, because addition order doesn't matter. It's going to get us the same result. All right, so moving on. Yeah, y less than or equal to 3. I'm going to cheat a little bit because I can. 1, 2, 3, horizontal line. You said it's going to be solid, right? Everybody okay with that? All right, and I'm going to shade. So did I want to shade above or below? Yeah, y less than or equal to, right? So we're going to shade below the line. So next equation, right? Where do I start when I graph these? At the vertex, which is negative 4, 0. 1, 2, 3, negative 4, 0. Yep, it is going to be a V. All right, make sure that it's a V, too. We don't want parabolas up here, okay? Parabolas have the rounded bottom. V's do not. So absolute value functions should be the intersection of two lines that should be crisp. So, again, I want where y is greater than for this, right? So that means that I want the bigger y. So where is y bigger? Inside the graph or outside the graph? So what I want you to look at, where's the biggest y? The biggest y is the arrowhead pointing up, right? Is this thing going to be inside the graph or is it outside the graph? Is it inside? Is it between the V or is it outside the V? It's inside the V, right? So greater than for absolute value functions in this style mean that I want the area between the V. So I'm talking about this region right here. No. If A is positive and it's greater than, then it'll be inside the V. If A is negative, the number in front of the absolute value function. If A is positive and it's less than, then it's outside the V. If it's less than and A is negative, it'll be inside the V. If it's greater than and A is negative, it'll be outside the V. The easiest way to do it is just not worry about memorizing all that garbage, but just look at the function. Okay? So the function here says, I want where y is bigger than the graph, right? Y is bigger than the line. The biggest y we have is the tip of the y-axis right here, right? That's the biggest y because that means it goes on forever. So is that going to be contained inside the graph, inside the function, or outside the function? It's inside my graph, right? So that means that I want this piece. This is where the y's are bigger. If my graph is here on the x, right? Where is the y bigger? Inside or outside? Inside, right? If you look at the same vertical line, these y's are bigger, so that's the region I want. So where is their overlap? So this is our solution area. Everybody okay with it? All right, so here's your homework assignment. If it were me, you're going to want to use rulers, you're going to want to use graph paper.